Welcome. Today's lesson is on the division rule for exponents. And we're going to keep this very simple today, and the IXL lesson will be very simple as well. Basically, what we're going to be doing is a lot of times we can express, or it's easier to express large numbers with exponents. So if I give you 234 raised to the sixth power, that's, if you put that in your calculator, that's going to be very, very large number. So we leave it like that. But what we're going to end up doing is let's take another 234 to the, say, fourth power. And so we're dividing by this one. Now, I want to emphasize that the the bases of the exponents are the same, 234, 234. And if the exponent on top is larger than the exponent on bottom, what we're going to do is we're just going to subtract this bottom exponent from the top exponent. So we get 234 to the 6 minus 4, or 234 to the 2 power, or the 2 exponent. And let me explain or show exactly why that is. Remember what this 6 means. It means that we have 234 times 234 times 234 times 234 times 234, 1, 2, 3, 4, 5, times 1 more 234, all over 4 of them. 234 times 234 times 234 times 234. Now, what I want to emphasize is that any number divided by itself becomes a 1. So that cancels. This one cancels. This one cancels. This one cancels. How many are left? So you'll see that the 4 on bottom canceled 4 of the 6 on top, leaving only 2. Now, the reverse is true if the exponent is larger on the bottom. Let's say I gave you, 999 raised to the 7th power over 999 raised to the 88th power. Well, remember, this 88 means I have 88 999s on the bottom of the fraction. I have 7 999s on the top of the fraction. So these 7 will cancel 7 of these, which leave how many 999s on the bottom of the fraction? It will leave 81. What's left on the top? A 1. So if the exponent is larger on the bottom than on the top, you're going to subtract the top exponent from the bottom exponent and leave the base with its exponent on the bottom under a 1. Right? So let's just do 2 quick examples, and then I'll let you get to work. So let's say I gave you 37 raised to the 44th power over 37 raised to the 28th power. First thing I'm going to ask myself, whoops, you can't quite see that. First thing I'm going to ask myself is which exponent is larger, the one on top or the one on bottom? Well, the one on top is larger, so I'm going to subtract the one on bottom, and I'm going to leave the 37 on top. There's going to be extra 37s on top. The 44 on top, we have 28 that cancel from these 44, leaving, 14 minus 8 will be 6. That had to borrow from the 4. 3 minus 2 is 1. So it'll be 37 to the 16th power would be your final reduced answer. Again, if I have, say, 83 raised to the 16th power over 83 raised to the 27th power, again, which exponent is the larger exponent? The exponent on bottom. So this time I'm going to leave the extra 83s on bottom, and how many will be left after I cancel 16 of these 27? Well, 7 minus 6 is 1. 2 minus 1 is 1. I'm left with 11 83s on the bottom and a 1 on the top. There isn't any 83s on the top. That doesn't mean it's a 0. One last thing. If you happen to get something like 80, I don't care. Let's do 38 to the 14th power over 38 to the 14th power. If the powers are the same, the number on top is the same as the number on bottom. It's just going to equal 1. If you do the division rule, you're like, well, do I subtract the top from the bottom or the bottom from the top? It really doesn't matter which way you go, but you get 38 to the 0 power. And I want to just reemphasize that anything to the 0 power, 14 minus 14 is 0, anything to the 0 power is 1. Or just remember, any number divided by itself is 1. As long as the exponents are the same, the whole big number would be the same. Good luck. If you have questions, bring them to class.